Let us start this workshop with a small prayer. Dear Heavenly Father, we come before you with hearts filled with gratitude and anticipation as we embark on the first day of our workshop on data analysis using SPSS. We acknowledge that you are the source of all wisdom and understanding, and we seek your guidance and blessings as we delve into this topic. In your divine presence, we place this workshop, its participants, and all our endeavors, and may our time together be enlightening, empowering, and transformative. We humbly pray all these things in your holy name. Amen. Good afternoon, all. It is my honor and privilege to extend a warm welcome to each and every one of you to this workshop on data analysis using SPSS. Today, we gather here with a shared enthusiasm for understanding and harnessing the power of statistical analysis in our data-driven world. First and foremost, I would like to express my sincere gratitude to our distinguished speaker, Dr. Kumaresan Sir, Professor Director, School of Commerce, KSR College of Arts and Science for Women, who have graciously agreed to share his expertise and knowledge in the field of data analysis. Your insights and experience will undoubtedly provide with valuable insights and equip us with necessary skills to navigate the complexities of SPSS, a powerful software tool widely used for data analysis. Dear participants, your presence reflects your commitment to advancing your skills in data analysis and your eagerness to explore the vast potential that SPSS offers. May this event be a stepping stone towards unlocking the true potentials of data analysis, enabling us to become more effective researchers, decision makers, and agents of change. Thank you, and let us make the most of this invaluable opportunity. Welcome you all. Now, I call Professor Venetia to introduce our resource person. Venetia, ma'am.
Madam, I think participants already know myself. Huh?
Wait, 1 minute, sir.
Yeah. Since time is going on, let
Yes,
me
sir.
start, I think.
Okay, sir. Okay, sir.
Yeah.
Okay, sir.
Thank you very much for your wonderful prayer and welcome. For the sake of new participants, let me introduce myself. I'm Dr. D. Kumaresan, Professor and Director, School of Commerce, KSR College of Arts and Science for Women, Tiruchengood. That's all. Most respected Brother and Secretary of Patrician College of Arts and Science, Madam Principal, Madam Academic Director, Head of the Department, faculty members, our Honorable Chairman, most respected Principal of our KSR College of Arts and Science for Women, Head of the Department, learned faculty members, and all my beloved participants, a warm and pleasant afternoon to one and all. At the very outset, I would like to thank the organizers for having given me a wonderful opportunity to be the resource person for the two-day workshop on data analysis using SPSS. It's really a great initiative because nowadays, you know pretty well, the research scholars, particularly MPhil and PhD research scholars, are in need of data analysis, whether it is primary data or secondary data. The data analysis is must, and everybody is expected to learn at least basic or fundamentals of data analysis. Pretty well nowadays, we have a lot of software. Software packages are there, predominantly SPSS, statistical package for social sciences. There is a most widely used software. Apart from this, we have a lot of softwares like R is there, NVO is there, eViews is there, like is Statistica. So several softwares are available. Anyhow, the SPSS is considered to be user-friendly, simple and easy to use, and it is giving accurate and reliable results, so that it is used most widely by the majority of the research scholars. In competition to this, R is also used, R Studio is used. Anyhow, as a first and initial step of this workshop, the organizers have asked me to tell something about the SPSS, data analysis using SPSS. In fact, it's an ocean. It requires tons of time to learn. This is just 1 hour duration today, 1 hour, and tomorrow 1 hour, 2 hours duration. Anyhow, let me try to do the justice. Within these 2 hours, let us learn something about the tests of hypothesis. See, basic things, data entry, data modification, and all, pretty well, data definition and all, basic fundamentals of SPSS, I think, or we hope that you might have learned. So let us start with the data analysis. When we talk about the tests of hypothesis, now there are two types of tests, that is parametric tests and non-parametric tests. What is parametric test and what is non-parametric test? You might have understood the concepts of parametric tests and non-parametric tests in different ways. Anyhow, it is my humble request to erase all your previous learning, because the very simple definition I can give you, that is, whenever a parameter is used for applying a test, it is called parametric test. If no parameter is used, it is called non-parametric test. So it is the simplest definition we can understand easily. So obviously your question will be, sir, what is parameter? You said when parameter is used for applying a tool, it is parametric test. Okay, I understood. Then what is parameter? In the very beginning of learning statistics, you might have learned measures of general tendency, measures of dispersion, you might have learned. Out of the measures of general tendency, there are averages, arithmetic mean, median, mode, harmonic mean, and geometric mean. Out of these, arithmetic mean or simply average mean, that is the most widely used average or measure of general tendency. In the case of measures of dispersion, range, interquartile range, that is quartile deviation, mean deviation, and standard deviation. Okay. So out of all these measures, the most widely used measures are mean and standard deviation. So they are called parameters. When the standard deviation is taken squared, it is said to be variance. So variance is another parameter. So for applying any tool, if we are using mean, standard deviation, or sometimes variance, it is said to be parametric test. If no such parameter is used, it is said to be non-parametric test. That's all. Okay. So what is parametric test? What are the different types of parametric tests? Don't worry, it can be divided into two categories. Broadly, it can be classified into two categories. That is t-test and ANOVA. T-test and ANOVA. Okay. So where should we apply t-test? Where should we apply ANOVA? That is the question. While applying the tool, we should keep in mind that appropriate statistical tool must be applied. What is appropriate? The most relevant. You know pretty well, at the roof of our house or at the top of our house, we are constructing a water tank. What is the purpose of this water tank? The purpose of water tank is to store the water, isn't it? Okay. Then we keep certain vessels like pots. We are keeping inside the house. The purpose of that pot or vessel is also to store the water. Okay. What about the water can or water bottle? That is also used to store the water. Water glass or simply tumbler is also used for storing the water. All these containers, water tank, water pot, water can, and water jug or water glass. Okay. The purpose is to store the water. But these containers are used in different ways. Can we drink water directly from the water tank? It is not possible. And the volume of water stored is huge. In the pot, the volume is less and it is used to carry inside the home. What about the water can or water bottle? It is used to carry to office, to college, to tour. Wherever we go, we take the water bottle. But what about the glass? It is used to drink water. So purpose is one and all for all the containers, but usage is different. So whenever we want to drink water, we cannot use the water pot or vessel or water tank. Sometimes we can use the water bottle, but what is most appropriate? Water tumbler or water kettle or jug or some tumbler or glass. That is usually used. Likewise, in the case of statistical tools also, we have to use the appropriate statistical tool. So for that, we should understand how to select the tool. Okay. I told you two types of parametric tests. Number one, t-test and ANOVA. Okay. Then the t-test is further divided into three types. Number one sample t-test. Number two, independent samples t-test. And number three, paired samples t-test. That's all. One sample t-test, independent samples t-test, and paired samples t-test. In the case of ANOVA, it is divided into two. One-way ANOVA and two-way ANOVA. That's all. Only 5 tests are there coming under parametric tests. Now let us see one by one. And where should we apply one sample t-test? Where should we apply independent samples t-test? Where should we apply paired samples t-test? Like that, let us see one by one. For that, let me show certain questions and let me show the database in the SPSS, how to apply the tool, how to analyze, how to obtain the result, how to interpret the results. That and all we will see one by one. Now let me share the problems. See, look at this. This is a one sample t-test, example for one sample t-test. This is the situation or this is the problem where we can apply one sample t-test. See, there is a college, St. Joseph College has conducted a coaching class for bank exam. So the college is conducting coaching class for a particular exam, TNPSC exam or UPSC exam or some bank exam like that. There is a competitive examination for that. This college is taking initiative to organize or to conduct coaching class for the students as well as the outsiders. Now the result has come. after conducting the examination by the concerned board, now the result is announced. After the announcement of result, we find that the average marks obtained by all the candidates who have attended or who have appeared for the examination throughout, it is found to be 150. Okay. Now this college claims that those who have attended coaching class in our college have performed better than the overall average of all the candidates. So here you just see average of all the candidates is given. Average means arithmetic mean. Average means arithmetic mean. So mean value or mean score of all the candidates. All means population. So population mean is given. Population mean is given. That is 150. Population mean is 150. Now the college says we have performed better than this overall average. Than this overall average. So in this case, we are taking only one sample. How many cases are there? We have taken 25 cases, 25 candidates, but all these candidates are given coaching by this particular college. That's all. So population is there. From the population, one particular sample is taken. This sample is not divided further, like age wise or gender wise or class wise or course wise. There is no such classification or discrimination. All the candidates, those who have attended coaching class in this particular college, have been taken together. So they are called as a single sample or one sample. That's all. So in cases or in circumstances like this, we have to apply one sample t-test. What is the condition? No classification of the sample respondents. All are considered as a single sample or one sample. No division, no further division. Number two, population mean must be known. Population mean must be known. Here population mean is known. It is 150. That's all. Here the marks obtained by each of the 25 students, 25 candidates have been given. The first candidate, whether that candidate is a boy or girl, whether he belongs to this age group or that age group, whether he belongs to first year, second year or third year, whether he belongs to UG or PG, that doesn't matter. We have not divided further. They are taken together. Only categorization is they have been trained by this college. That's all. Or they have undergone coaching in this college. That's all. Okay. Now, what is the question? You are required to test whether the claim made by the college is correct or not. What is the claim? We have done better. We have done better than all the candidates. Okay. So this is the case. Understand the situation. Population mean is given, that is 150. Population mean is given 150. Then individual marks are given. Okay. Then no division. No boy or girl, first year, second year, UG, PG, rural, urban, married, unmarried, no division. That's all. In this case, we have to apply one sample t-test. So before applying any test, we have to formulate the hypothesis. Hypothesis, SIS is singular, SES is plural. Hypothesis, there are two hypotheses. Number one, null hypothesis and alternative hypothesis. What is null hypothesis? There is no significant difference between the average marks obtained by the SJC candidates and overall average marks of all the candidates. That's all. So here population mean is 150. We don't know the sample mean. The null hypothesis they says that there is no significant difference. There may be a difference, but the difference is not significant. So the null hypothesis H naught is considered as population mean is equal to sample mean. That's all. Then only we can say that there is no significant difference. So obviously alternative hypothesis will be there is a significant difference. That's all. Now we will go to the database. Those who have installed the SPSS in your laptop may open this for the sake of time saving. I'm showing the database. So this is the database. Let me share the database later. See here, you see the variable view. Marks are given. First one, marks obtained. Okay. So that is the data required for this problem. I have given the data set for all the problems. Now this is the only variable we have to take for this problem. So marks obtained by, see, look at this. First by, first candidate, 160, 143, 175. So that is entered here. Last candidate, 187. So this one is entered. Right. What test we have to apply? What is the most appropriate test we have to apply? One sample t test, because the entire sample is considered as a single group. There is no further division of groups, no classification, single sample. All the sample respondents are considered as a single group. So there is no division. One condition. Number two, we know the population mean. That's all. Right. Now how to apply the test? We have understood the situation. We have understood the test to be applied. We have understood the conditions to be fulfilled for applying this tool. Okay. Now, how to analyze? For all the statistical analysis to be applied, this is the only gateway. Look at the menu bar. In this menu bar, sixth menu. First menu file, second one edit, third one view, fourth one data, fifth one transform, sixth one analyze. If you click on this, you can find lot of submenus in the drop down menu. This is a drop down menu. Here we have lot of items. Okay. Now for applying the parametric test, we have to select the fourth one in the drop down menu, that is compare means. Okay. Another sub window is opened. So in this sub window, you can find there are 5 choices. Number 1 means, number 2 one sample t-test, number 2 independent sample t-test, number 4 a paired sample t-test, and number 5 one-way ANOVA. Now which test we have considered as the most appropriate one for this problem? We have chosen this one sample t-test. So you select that one sample t-test. If you open or if you click on that, a window will open like this. A window is appearing like this. There are 2 boxes, on the left-hand side box, all the variables are entered. Because whenever we enter the data in the data set, it is shown here. So from this, we have to select the variable and it should be taken to the right-hand side box. Right-hand side box is the test variable. So left-hand side box is the list of variables. From this list of variables, we have to select the particular variable and it should be transferred to the test variables box. So here, what is the variable we have to choose? This one, marks obtained by the SJC candidates. Okay. There are 2 ways to transfer this to the next box. One is you select and just drag it. That's all. or otherwise simply select and use this right arrow. Yeah. Okay. So it is moved to the test variable box. So here options box is there. In this option box, in default confidence interval is given. You no need to do anything. See here, test value is there. Here only you should be careful. Keep in mind the population mean. No, what is the population mean here? 150. That 150 should be entered here. That's all. If you don't enter this, it is not correct. So first, let me repeat the procedure. Go to analyze, compare means, select one sample t-test. We have all the variables. Select the particular variable, then enter the population mean. Just click OK. This is the result. Now let me come back to the Word document once again. The same result have been copied and pasted in this Word document. Look at this. This is a sample t-test result. Okay. Here t value is given, degrees of freedom is given, p value, probability value is given, mean difference, then confidence interval, lower limit, upper limit is given. In the top table, number of respondents, mean value of the respondents. That is, this is the sample mean, sample deviation, standard deviation, and standard error. Now, first we have to start with second table. Look at the 150 test value. That population mean we have entered. No, that is displayed here. Okay. Now, this is the result. We have to start with this p value. We have to start this with p value. So what is the p value here? 0.019. 0.019. You just understand the criteria. If the p value is less than 0.05, if the p value is less than 0.05, then we have to make the decision, or we have to conclude that it is significant at 5%. If the p value is less than 0.05, the result is significant at 5%. If the p value is less than 0.01, understand, less than 0.01, then the result is significant at 1%. If the p value is greater than 0.05, the result is not significant. So these are the three criteria we have to keep in mind. Number one, normally we check the 5%. 5% means 0.05. If the p value is less than 0.05, let us conclude that it is significant at 5%. See, what is the p value here? 0.019. Let us check whether it is less than 0.05. Yes, it is less than 0.05. Once again, we shall check whether it is less than 0.01. No. It is greater than 0.01, but less than 0.05. So it is significant at 5%. That's all. So the result is there is a, see here, what are the two hypotheses? Null hypothesis. If the p value is less than 0.05, null hypothesis is rejected. If it is rejected, obviously the alternative hypothesis is selected. What is alternative hypothesis? There is a significant difference. That means population mean is not equal to sample mean. Population mean is not equal to sample mean. Okay. Now we understand that there is a significant difference. Okay. There are two possibilities. If there is a significant difference, then the sample mean may be too high or higher than the population mean. This is one of the possibilities. Another one, even though there is a significant difference, it's another possibility. Yes, the sample mean may be far below than the population mean. So we have to check the sample mean. What is the sample mean here? I told you no. This is the sample result. Number of items 25. Sample mean 166.84. What is the population mean? 150. So sample mean is higher, greater than the population mean. So the conclusion. What is the question? Can you say that the candidates of this college have performed better than the overall average? Yes, because overall average is 150. Average marks of our students is 166. So let us say, let us be proud that our candidates have performed better. So this is the case where we have to apply one sample t-test, and this is how we have to apply, this is how we have to interpret the result. Okay. Now we shall move on to the second question. Second type of t-test. Here, independent samples t-test. When we talk about the independent samples t-test, we should understand
Sure.
okay, ma'am. Okay, sorry. Call on Zada. அருள் பிரபு. Is it okay, madam, now?
Yes, sir.
Okay. So there are two types of caps, Ola and fast track. In this case, we have to apply independent samples t-test. So before that, as usual, we have to write the hypothesis. There is no significant difference between number of journeys booked by fast track and Ola. That's all. Now we will go to the data. Look at this. Number of journeys booked and cab operator's name is given. They are entered into two different columns, two different variables. Look at this. Number of journeys and the cab operator's name. Okay. Now, once again, the same gateway, analyze, compare means, go to independent samples t-test. See here, what is the test variable? See here, can you say the number of bookings is more than a number of bookings of fast track? Ola is more than fast track. So number of bookings is the dependent variable. So here, this is the test variable, that is number of journeys booked. What is the grouping variable? Name of the cab operator. But here, one more thing we have to do, define the groups. How many groups are there? Only two groups. So group 1 is 1 and group 2 is 2. That's all. So continue. Then click OK. So look at this. This is the result. First one, as usual, sample descriptives, and second one, t-test result. So first, we have to start with this. Once again, I'm coming to the Word document. See here. See here, the results are given in two columns. Number one, Levin's test for equality of variance. Now we are testing for equality of means. So let this be dropped. The first column results may be dropped. So let us take the results of the second column. So that is given here. Here is also the results are given in two rows. First row, equal variances are assumed. Second row, equal variances are not assumed. I told you what is variance. Variance is the square of standard deviation. See here, standard deviations of two cab operators are given. Ola 65 point. Six. What do you mean by variance? Square of standard deviation. If the variances are equal, the standard deviations must also be equal. Here, these standard deviations are not equal, so we take the second row of the results. So here, look at this. P-value 0.000. It is less than 0.01. Straight away, we can see that it is less than 0.01. So there is a significant difference between the number of journeys booked by fast track and Ola. It is significant at 1%.
Sir, we can't hear you.
whether Ola has got. Okay, madam.
Okay, sir. Okay, sir.
Okay, sorry. So look at this. Mean value of Ola 250.28. Mean value of fast track 174.58. So which is greater, Ola? So question is whether Ola has got more bookings. So result is yes. It is concluded that Ola has got more bookings than fast track.
Sir, it is
So
not
this
visible, sir.
not visible.
Yes, sir. Yes, sir.
Wait a minute, ma'am. Is it okay, ma'am, now?
No, sir.
For me, it is showing that it is sharing, ma'am.
It's not visible, sir, and we can't see you also, sir.
Ma'am,
It's not visible, sir.
is it visible now, ma'am?
No, sir.
This one?
No, sir. No, sir.
What happened, ma'am? For me, it is showing that it is a shared, ma'am.
So, close the screen presentation. You can again try to share the PPT, sir.
Yes, ma'am. Now?
No, sir. Otherwise, you
Or shall I,
just log out and then again you can log in, sir.
ma'am?
Can you log out and again you can join, no, sir? You can try it like that.
Okay, ma'am. Okay. Is it visible, ma'am?
Yes, sir. Yes, sir. Now
Okay,
it's
thank you.
visible, sir.
Okay, thank you very much.
Thank you, sir.
So the question is whether Ola has got more bookings than fast track. The result says that it is yes. Okay. Now the third type of paired, t-test, that is paired sample t-test. Here, it is like both. First one sample t-test, no categorization. Second one, categorization, but here, no categorization, but data are collected for two different periods. So before, after, pre, post, like that. Here also, all the 25 respondents are taken together. They are not categorized. Okay. So that is the difference between one sample t-test and paired sample t-test. Similar to the one sample t-test, except there are two data. That's all. See here, monthly average grocery purchases of 25 families are given before lockdown and after. Grocery alternate hypothesis, there is a significant difference. So now let us go to the data. So data before lockdown, data after lockdown. Once again, go to analyze, compare means, then paired samples t-test. So average grocery purchases before lockdown, average grocery purchases after lockdown. That's all. It is paired automatically. Now go to OK. So now there are three tables of results. The table results are given in the Word document. Look at this. Okay. See here. This is the paired samples t-test result. Once again, we are going for p-value. It is 0.796. P-value is greater than 0.05. If it is greater than 0.05, null hypothesis is accepted. If it is accepted, there is no significant difference. That means the average purchases of groceries have not been affected by the lockdown. Just look at this. Mean average purchases before lockdown 1617, after lockdown 1632, just a 15 rupees difference. That is statistically proved that there is no significant difference because p-value is greater than 0.05. So conclusion, it is concluded that the lockdown has not affected the monthly average grocery purchases of the sample families in this particular location. That's all. So that's all about the t-test, one sample t-test, independent samples t-test, and paired samples t-test. Now let us go to the other part of parametric test, that is one-way ANOVA and two-way ANOVA. Okay. I told you know, if the independent variable is divided into more than two categories, in that case we have to apply ANOVA. What is the difference between one-way ANOVA and two-way ANOVA? Look at this. This is the problem for one-way ANOVA, and this is the problem for two-way ANOVA. In this case, there are two independent variables, one dependent variable. But in this case, one dependent variable and one independent variable. So if there is one independent variable and one dependent variable, we have to go for one-way ANOVA. Condition is independent variable is divided into more than two groups. A dependent variable is scale data. Here look at this dealer, distributor, two groups only. But zone is divided into four groups. So either of this, these two independent variables is divided into more than two groups. So we go for two-way ANOVA. Now let us come to one-way ANOVA. The food delivery service providers are there: Swiggy, Zomato, and Uber Foods. So there are three food delivery service providers. We have obtained the overall satisfaction score from our respondents. 63, 40, 58, 49, like that. Scores are given, not grades, not highly satisfied, satisfied, not like that. Here we have obtained the scores. If the scores are obtained, it is a scale data. In that case, we have to apply one-way ANOVA. So as usual, we write the null hypothesis and alternate hypothesis. There is no significant variation in the overall satisfaction of customers of three different food delivery service providers. Now we will go to the data analysis. See, these are the items given, that is satisfaction score and type of food delivery service providers. Go to analyze, go to compare means one way ANOVA. Look at this dependent list. What is the dependent list? Overall satisfaction score. Then score, factor is food delivery service provider. That's all. Then click OK. So only one table. Result contains only one table. Now let us go to the Word document. See, this is the result. Between groups, within groups, p-value is 0.093. 0.093 is obviously greater than 0.05. If the p-value is greater than 0.05, then null hypothesis is accepted. What is null hypothesis? There is no significant variation. That means the satisfaction of customers of the three food delivery service providers did not vary significantly. There may be some differences, but the difference is not significant. That is what we conclude from this. So this is called one-way ANOVA. Now let us go to two-way ANOVA. There is a company. It sells products through retailers belonging to different types of zones. So annual turnover is given. That is dependent variable, because question is whether the annual turnover varies in accordance with retailer and zone. So turnover is the dependent variable. Retailer and zone are the independent variables. There are two independent variables. So we apply two-way ANOVA. In the previous case, there was only one independent variable. So we applied one-way ANOVA. Now we apply two-way ANOVA. As usual, null hypothesis. But here, unlike the one-way ANOVA, we have to write three null hypotheses. Number one, there is no significant variation in the annual turnover according to retailer. That is one of the independent variables. What is the another independent variable? Zone. So there is no significant variation in the annual turnover according to zone. And what is for the third null hypothesis? It is for the interaction of retailer and zone. So there is no significant variation in the annual turnover according to retailer zone interaction. Now we go to the data. This is the data set. See, retailer, zone, turnover. Turnover is the dependent variable. Retailer and zone are independent variables. Go to analyze. Compare means over. Now go to the general linear model. General linear model, univariate analysis. Why it is called univariate analysis? There is only one dependent variable considered. If more than one dependent variables are considered, it is said to be multivariate analysis. Okay. Now here only one dependent variable. There are two independent variables, but dependent variable is one, that is annual turnover. So click OK. So what is the annual turnover? Dependent variable. I mean, that is called dependent variable. Then what are the two uh, independent variables? Type of retailer and zone, to take it to the fixed factors. That's all. Then go to OK. So this is the result. There are two tables. Now come to the Word document. Look at this. There are three results. As we have formulated three hypotheses, there are three results. Number one, according to retailer. According to retailer, p-value is 0.569. It is greater than 0.5. So there is no significant difference in the annual turnover of retailers according to the type of retailer. Number two, zone wise. Yes, the p-value is 0.000. That means it is significant at 1%. Then both ways also it is not significant because p-value 0.332 is greater than 0.05. That's all. Now, what can we conclude? It is concluded that the annual turnover varied significantly among the four zones or according to zones. Okay. Now, one more question for the sake of understanding. We said there is a significant difference between the zone-wise turnover. So which zone has done better, or which zone has given the best performance? Which zone has given the worst performance? For that, you have to go for one more analysis. Go to this. Again, go to analyze here, compare means. Go to means. Go to means. Dependent variable, annual turnover. Independent variable, zone. That's all. Now check this. East zone, 61.13. West zone, 28. North zone, 40. South zone, 80. So which zone has given the best performance? South zone, 80. Which zone has given the worst performance? West. It is 28. So likewise, we have to write the interpretation. There is a significant difference in the annual turnover according to zone, but not according to retailer or both the retailer and zone. Like this, we have to write the interpretation. So these are the two types of ANOVA, one-way ANOVA and two-way ANOVA. Overall parametric tests, it is divided into two. One is t-test and the other is ANOVA. T-test is divided into one sample t-test, independent sample t-test and paired sample t-test. ANOVA is divided into one-way ANOVA and two-way ANOVA. So these are the situations where we have to apply parametric tests. I hope you all might have taken at least a little knowledge. With this, I would like to conclude with sincere gratitude to the organizers for having given me wonderful opportunity, and my sincere thanks are due to all the participants for the patient listening. And due to technical problem, there was an interruption twice. I'm extremely sorry for that technical problem. Let me try to continue tomorrow's session without any interruption. Thank you very much. Thank you, all of you, once again.
Thank you, sir. Thank you so much.
Now, if there is any question, you can ask.
Participants, if you have any questions, you can raise your hands. Vishnu, sir, Professor Vishnu, you can ask your question.
Good evening.
Very good evening, sir. Yes.
It's a very useful session for us.
Thank you very
Sir,
much.
can you explain once more where we use the independent sample? That time we got some difficulty related to the audio and the internet problem. So can you please
Which one?
explain
Which
that
one?
when we used independent sample t-test?
Independent sample t-test. Okay.
Yes.
So in the case of independent sample t-test, the independent variable is divided into two groups only, like VOLA and fast track. There are only two groups of independent variables. In that case, we have to apply independent sample t-test. Okay.
Okay, sir. Can you share the data set for further?
Yeah, I will share. I will share with you.
Okay, thank you, sir.
Thank you very much. Jitu, Doyle, you can ask. You can unmute your mic and ask. Jitu? Deepak Biswas. Unmute your mic and ask question.
Sir, one question from chat box.
Yes.
If one variable has no impact, other has impact, how it will be combined and has no impact, though not related to SPSS.
Yeah, in this case, we have shown no two-way ANOVA. One variable, that is retailer, type of retailer, dealer and distributor. Another variable, the zone. So two independent variables are there, out of which the result said that there is no impact of type of retailer, but there is an impact of zone. So there can be no. Similarly, there can be a combined effect of both of the variables. But most probably, if one variable has no impact, then
Sir, we can't hear you, sir.